Hello and welcome to York Observatory's TeleTube, the online astronomy and astrophysics program written and presented by the students, faculty, alumni, and friends of York University. I'm Gagan and I'll be one of your hosts this evening. I'm joined by Noah, Matt, and Amin, broadcasting live from the Alan I. Carswell Observatory located in Toronto, Ontario, Canada. Tonight, we've got a great presentation about nebulae. TeleTube broadcasts on YouTube every Wednesday night at 7:30 p.m. local Toronto time. For any questions or comments you have of our past shows, or if you have suggestions for future topics, please send us an email at observe@yorku.ca. You can also connect with us on Twitter or Instagram with the handle at York Observatory and on Facebook at Alan I. Carswell Obs. Before we get started with the main show, we want to give you a little update on what you can see stargazing this week. The moon is currently in the waning crescent phase and will rise tonight in the east at about 3 a.m. and will be visible through the morning. New moon will arrive on Monday night. We also have the Pleiades in the east, which will be visible almost all night and set in the early morning. The Pleiades are an open star cluster containing thousands of stars and also a nebulous cloud, and appear as a small collection of 6 to 7 stars in most night skies. But if you're lucky enough to have exceptionally dark skies this week or have a telescope, you'll be able to see a lot more. The constellations Taurus and Orion will be rising following the Pleiades in the east, so keep your eye out for the bright red bullseye Aldebaran and Orion's Nebula under the 3 stars of Orion's belt. The Andromeda Galaxy is another object high in the sky this evening and will be setting a few hours after midnight, but you'll most likely need a telescope or binoculars with very dark skies to see it. We've also got a few planets with great views. Mars is high in the southeast right now, and Saturn and Jupiter are just about to disappear below the southwestern horizon, but they'll be visible in the early evenings. You'll be able to see the Pleiades, Mars, Jupiter, and Saturn, as well as other stars and the moon with your naked eye. But if you'd like to see a little more detail on the moon and other objects, a pair of binoculars or a small telescope is a great aid. Saturn and Jupiter are actually heading towards a conjunction on December 21st, and we'll be doing a special event at the observatory to celebrate. Saturn and Jupiter will appear to us the closest since 1623 at just 0.1 degrees apart, and can even be viewed together with our 1-meter telescope. Tune in on Monday, December 21st from 4 to 6 p.m. Toronto local time on our YouTube channel for this stream. You can find more information about this event on our website, observatory.info.yorku.ca. Now, Professor Hyde will be showing some images taken this Monday during OPV at the observatory.
Thank you very much, Gagan. Indeed, we would usually try to go to live images from the telescope, but it is too cloudy tonight. So we're going to do the next best thing and show you what you could see through the eyepiece of the 1-meter telescope if it was clear. And in fact, most of these images we collected just this week on Monday during the OPV. And as Gagan mentioned, we can, of course, see Mars and actually Neptune and Uranus are up as well. And if you had a telescope, you would be able to make out these fainter objects. But as you go out and out into the icy solar system, especially for the blue Neptune and Uranus, it gets to be, well, rather hard to see without assistance. So we're quite happy we can bring you this sort of collection of red and blue, not just planets, but also stars, and Aldebaran being a red star. We also had the Pleiades, which you can see with your naked eye, but also look very, very fabulous through the telescope. And the Pleiades is actually going to give me a little bit of a segue here, because you are going to hear a bit about the Pleiades in tonight's TeleTube. It is, in fact, a nebula. No spoilers, but it is, going to be covered in our talk tonight. And the Pleiades has a little bit of interesting history as well. Some of you might remember from our Halloween episode. The Pleiades is an object that you can see in the sky with stars next to each other, but unlike constellations, these stars are actually physically next to each other. The Pleiades is sometimes called the Seven Sisters, but an interesting little FAQ, these you cannot see 7 with your naked eye, no matter how good your eyesight is. So why are there 7 sisters in the Pleiades, and why do we find this same story across the world? Well, many Indigenous legends, especially from the Aboriginal communities of Australia, actually say that one of the sisters dies or was taken away. And in fact, this would have happened because one of the stars is thought to have varied in brightness rather substantially about 100,000 years ago. So as we're going on to learn about nebulas, and in particular this nebula and several others, I'll just, leave you with the thought of, if one of these stars was visible to the naked eye 100,000 years ago, is the legend of the 7 sisters 100,000 years old? So we'll go on to learn all about all kinds of great nebulae. And to take us off, we'll get started with our main part of our show. Our first presenter, Amin, is going to tell us a bit more about what a nebula is. Take it away, Amin.
In short, a nebula is a giant collection of dust and gas in interstellar space. The main types of gases in nebulae are hydrogen and helium, which makes sense because these are the most abundant chemicals that exist in the universe. Originally, any diffuse object outside the Milky Way was considered to be a nebula. This changed in the early 1900s when advances in astronomy allowed for better classifications of celestial objects. It turns out that many objects that were initially called nebulae were actually something else. For example, galaxies outside the Milky Way were discovered and were no longer considered to be nebulae. More on this later. Nebulae are quite large objects. Some of them are hundreds of light years in diameter. Over time, gravity will cause these large nebulae to slowly contract and eventually collapse into themselves. Space telescopes are very useful for detecting nebulae, and many of the famous nebulae images you may have seen came from space-based telescopes. Matt will go into more detail about types of nebulae, but I will give an introduction here. Galaxies were initially called spiral nebulae due to their shape. Star clusters were also classified as nebulae. Most objects that are called nebulae right now are diffuse objects. This means that they are extensive and have no well-defined boundaries. Diffuse nebulae can be further subdivided into emission nebulae, reflection nebulae, and dark nebulae. These categories are named after how the nebulae interact with light. The other major type of nebulae are planetary nebulae. These are formed when stars die and eject gas into space. Protoplanetary nebulae and supernova remnants also exist. Stars have different deaths depending on their size. Large enough stars, at around 8 to 9 times the size of the Sun, can create a supernova when they die. This is essentially a large explosion. Smaller stars like our Sun will grow in size into giant stars and then eject their outer layers. Both types of star death can create nebulae. Some nebulae form from gas that already exists between stars. These are called giant molecular clouds. Other nebulae form from the materials ejected by the deaths of stars. Gravity holds the dust and gas together. Different abundances of materials present in different nebulae give rise to color differences. Nebulae also have various different shapes due to being diffuse. If you have seen pictures of nebulae, you may note the great variety in both shape and color, as well as the beauty of the nebulae. Once stars start being created in nebula, this gives a source of light, which then allows for us to be able to see the nebulae from Earth. Other types of nebulae do not have stars themselves, but reflect the light of nearby stars, or are quite hot in temperature and radiate. Most nebulae are composed of about 90% hydrogen, 10% helium, and 0.1% heavy elements such as carbon, nitrogen, magnesium, potassium, calcium, or iron. Hydrogen makes a red color, helium blue, oxygen green, and interstellar dust can create a large variety of colors. Nebulae are often called star factories or star nurseries. This is because stars are created from the dust and gas present in them. Nebulae are themselves formed from the deaths of stars, so this leads to a cycle in the universe. Gas is recycled from stars into nebulae and then back again. Some gas, however, has still never been in a star yet. Once a nebula has enough mass, it will not be able to withstand the force of gravity and it will collapse. Gas pressure will no longer be able to push back against the gravity. After collapse, stars can be formed from the hydrogen and helium. The colder the nebula is, the smaller the created stars will be, due to the lower amount of energy present. Often a large amount of stars can be created at the same time, creating an open cluster of stars. We can actually observe nebulae and watch the forming protostars as they form. Planets, asteroids, and other objects present in a star system are also created from the material in the nebulae. Stars can create heavy elements like iron and eject these elements into space when they die. These materials can then enter planets. We are all made of star stuff. Space telescopes such as NASA's Spitzer Space Telescope and the Hubble Space Telescope have captured many images of faraway nebulae. These telescopes have many benefits compared to ground-based telescopes. For example, they don't have to worry about the atmosphere or light pollution. They can see some wavelengths of light that cannot penetrate Earth's atmosphere. Spectroscopy, which we talked about in last week's TeleTube, can be used to detect the types of elements present in the nebula. Each element has its own signature spectral features that allow it to be identified. Some nebulae can be seen by the naked eye, but the invention of telescopes and photography allows for better quality observing. Color is often added into pictures of nebulae. This is because the real color is usually too faint to be detected from Earth. We can detect the wavelength of emitted radiation, but color is a subjective experience created by the human brain. Taking images with longer exposure time helps, but not enough. Color can be added to nebula images to represent what it would look like if you were there. The process is not perfect, but it may be better than black and white. This is actually a controversial topic. What do you think? Should color be added to astronomical images? And now Gagan will talk about the history of nebula discoveries. Go ahead, Gagan.
Thanks, Amin. Nebulae have caught the attention of stargazers for hundreds of years, but it wasn't until recently that they were defined on specific terms. Early astronomers named a lot of things they saw in nebulae, but they didn't have many ways to look closer and figure out what they were seeing. The earliest records we have of nebulae being observed go back almost 2,000 years ago. Ptolemy recorded several nebulous regions of the sky, including what is now known as Ptolemy's cluster, an open star cluster in the constellation Scorpius, as early as 130 AD, and similar observations continued over the next few centuries. The word nebula is derived from the Latin words for cloud and gas. To the unaided eye in a dark sky, most deep sky objects look simply like a cloudy area of brightness in the sky. So naturally, star clusters, galaxies, and nebulae, as well as some other diffuse objects, were all categorized together as nebulae. Even the Andromeda Galaxy was initially classified as the Andromeda Nebula. The first recorded instance of a real nebula or related object that was not a galaxy or cluster was in 1054, which was the supernova that created the Crab Nebula. This supernova was so bright it was visible during the day and was recorded by Arabic, Chinese, and Native American Chaco Canyon astronomers as a new star. However, it would not be until the 1700s that the Crab Nebula would actually be identified as such, and it took even longer to connect the nebula to the supernova responsible for its creation. Another notable supernova that led to a nebulous formation is the Kepler supernova in 1604. This was another bright supernova that was visible for weeks, even in daylight, and was recorded by astronomer Johannes Kepler. The supernova remnant nebula is shown on the left. The first official nebula to ever be identified was the Orion Nebula. In 1610, the French astronomer Puresque discovered it using a telescope, which is not much of a surprise, with the Orion Nebula being the brightest nebula in the sky. It is easily visible with a pair of binoculars and dark skies, or even with the naked eye. Several other astronomers in the 1600s also identified the Orion Nebula, and a couple of them all thought they were the first to observe it. Comets were another object, in addition to galaxies and clusters, that were sometimes mistaken for nebulae or vice versa. In the 1700s, astronomer Charles Messier set out to research comets, and he was tracking Halley's Comet in particular. Here, the Crab Nebula makes another appearance. Messier initially mistook the Crab Nebula for Halley's Comet, but it wasn't until he continued to observe it that he realized that it was not moving in the sky like a comet usually would. Messier decided to compile a list of fixed nebulous objects, or nebulae, so he wouldn't confuse them with comets in his research, and the catalog is still used commonly today as an excellent observing guide. However, the contents of the catalog have since been updated and recategorized, as many of Messier's nebulous objects were actually galaxies and clusters. The Andromeda Galaxy, which is one of the closest large galaxies to the Milky Way, was thought to be a nebula for a very long time. Its classification was actually the subject of a significant debate in the astronomy community. When research was done by Hubble on the stars in the Andromeda Nebula, they were proposed to be too far away to be within the Milky Way. The Andromeda Nebula, then, must not have been a nebula at all, rather its own galaxy. Prior to this discovery, the Milky Way galaxy was thought to be the only such structure in the universe, and the discovery of another was big news. The discovery also prompted astronomers to reevaluate the nebulae they had previously identified, and they realized that many of these nebulae were actually more distant galaxies. While a lot of the history behind nebulae and the research is mixed in with galaxies, clusters, and other celestial objects, the study of nebulae propelled one of the biggest breakthroughs in astronomy history. Over time, astronomers better defined different celestial objects and even went on to categorize different types of nebulae. Now, Matt will go through all these types of nebulae.
Thank you. Thank you so much. Well, now that we know what they are and how they are formed, we can go a little deeper into the types of nebulae we can find in our universe, right? So the first one that I'm gonna mention is the emission nebulae, which are clouds of ionized gas that, as the name suggests, emit their own light at optical wavelengths, and um, their mass generally ranges from 100 to 10,000 solar masses, so you can imagine how big they are. And this material can be spread out over a volume of less than light years to several hundred light years. So for these reasons, their density are highly varied, ranging from millions of atoms over a cubic centimeter to only a few atoms over a cubic centimeter, depending on the compactness of the nebula. Typically, they have densities of the order of 1,000 atoms over a cubic centimeter, which is extremely rarefied compared to the air we breathe on Earth. And their average temperature, though, is around 10,000 Kelvin, which is extremely hot. One of the most common types of emission nebulae occurs when an interstellar gas cloud dominated by neutral hydrogen atoms is ionized by nearby O and B type stars. These are extremely hot and luminous stars that give off vast quantities of high energy ultraviolet photons, which break the neutral hydrogen atoms into hydrogen nuclei and electrons. These later recombine to form neutral hydrogen again, but this time in an excited state. As the neutral hydrogen atom returns to its lower energy state, it emits photons at wavelengths equivalent to the energy difference between the allowed energy states of hydrogen, producing these different colors. And there are these two subtypes of emission nebulae. There's the red emission nebula, which is the light from hydrogen atoms, as I mentioned before, and then there's the blue reflection nebula, which is only the dust reflected by the starlight of the O and B type stars. Then another common type of emission nebula is the planetary nebula, actually. These objects consist of a central white dwarf star surrounded by clouds of gas released as the original star evolved into the white dwarf phase. And in this case, the excited gas is not necessarily dominated by ionized hydrogen as before with the emission nebula, but can also contain significant amounts of ionized helium, which is the blue emission we can see on the pictures, and the doubly ionized oxygen, which is the green part we can see on the images. Since much more energy is required to ionize helium than hydrogen, the bluest areas of the planetary nebula are the hottest, and they indicate the areas of highest excitation. Most probably the sun, actually our sun from the solar system, will form this type of nebulae in about 5 billion years. And even though their name can mislead people to think that they have something to do with planets, they are called planetary because they have a round shape when looked from a telescope, from a small telescope specifically. And one example of a planetary nebula is the Ring Nebula located in Lyra, which is the image on the left. There are many outstanding questions, though, about the process of planetary nebula formation. One puzzling aspect is how such a wide variety of shapes and nebula properties are formed from a material ejected from a spherical star, though it's a spherical, so we have very linear shapes, not only spherical shapes for the nebula. And very few nebulae actually have the simplest structure of a round shell, and actually most of them are bipolar or butterfly shaped or even elliptical. And somehow the material from the star is transformed into these complex shapes. And also there's evidence of jets and clumps being ejected at various times during its formation. The complex structure of the Helix Nebulae is shown in the image to the right. This Helix Nebulae is thought to have an overall bipolar shape, actually, which is not round, but appears ring-like because we're viewing it nearly pole on. Now, there's another type of nebulae, the dark nebulae. They are interstellar clouds that can contain a very high concentration of dust. This allows them to scatter and absorb all incident optical light, like we saw with the blue emission nebulae, making them completely opaque at visible wavelengths. They are most obvious when located in front of a bright emission nebulae, like the Horsehead Nebula in Orion, or in a region that is very rich in stars. The average temperature inside these dark nebulae ranges from about 10 to 100 Kelvin, which is not a lot compared to the emission nebulae, and but it is still allows hydrogen molecules to form and the star formation to take place. These large dark nebulae can contain over a million solar masses of material, and the ones that extend over 200 parsecs are known as giant molecular clouds, while the smallest ones are called Bok globules, and they tend to be less than 3 light years across, and they can contain less than 2,000 solar masses of material, which is a lot, but not a lot compared to the other types of nebulae. They are physically similar to the reflection nebulae, which I'll be mentioning after this one, but they differ in the geometry of the light source. In other words, the placement of the light, the cloud, and our Earth. And now we had nebulae that emit, so it would be kind of logic for us to find a reflecting one, right? So if your answer was yes for this question, then you're actually correct. Indeed, a reflection nebula is created when light from a star is scattered or reflected off a neighboring dust cloud. The scattered light is slightly polarized and has a spectrum similar to that of the illuminating star, only bluer. This shift in color arises because the typical size of dust grains in the cloud are comparable to the wavelength of the blue light. The result is that blue light is scattered more efficiently than longer red wavelengths, and given the characteristic blue color of for this nebulae, like we saw with the emission nebulae, the blue emission nebulae as well. Um, Reflection nebulae are usually less dense than dark nebulae, and they have sizes that are determined by the source of illumination. Their extent is not defined by the size of the dust cloud, but rather the area over which the brightness remains above the point of detection. The nebulosity surrounding the stars in the Pleiades, which is the image shown right now, is perhaps actually the most well-known example of a reflection nebulae. And lastly, well, we know that the universe is an interesting place, which means we can find not only what is expected, but something like a mix of everything. In our case, there are some nebulae that do not only show a reflection or emission type, but both, or even more. So one example of a combination of an emission, reflection, open cluster, and dark nebula in one single stellar object is the Trifid Nebula. The word trifid means divided into three lobes, which is a name that describes the nebula perfectly since it is divided by portions. The upper portion we can see is where the emission nebula is located. Hence, that's why it produces a red color. The lower portion is where the reflection nebula is, and it gives this part a blue color. And finally, the gaps within the emission nebulae they will produce a trifurcated appearance due to the presence of the dark nebula. Well, the Trifid Nebula is a star-forming region located in the Milky Way, by the way, if you're interested in looking at it. But that's not the only interesting mysterious nebula out there. And because of that, NOAA will be showing us more unique and popular nebulae found across the universe.
Thank you, Matt. Throughout this presentation so far, I'm sure you've noticed how incredible and majestic nebulae are. But what are some popular, unique, or interesting nebulae that are commonly viewed or studied? Often, names such as the Orion Nebula, the Eagle Nebula, the Ring Nebula, and the Crab Nebula arise. These nebulae are some of the most popular and well-known. For starters, let's discuss the Orion Nebula, or Messier 42. My personal favorite, it is the brightest nebula visible from Earth. Although 1,500 light-years away may seem distant, it is, in fact, the closest stellar nursery, becoming visible at night, directly below the Orion's Belt constellation, with an apparent magnitude of 4. Something unique about the Orion Nebula is that you can find 4 stars around its core, which together form the trapezium cluster, stars that were actually formed within the nebula itself, and not only shape the abundance of gas and dust around themselves, but stunt the growth of other nearby stars. Next, the Veil Nebula. This nebula is actually formed from a myriad of debris from an incredibly massive star, 20 times the mass of our Sun to be exact, a star that had become supernova 8,000 years ago. The nebula is composed of gas that had been emitted directly before the explosion. This nebula is enormous at a whopping 110 light-years in width, so large that, from our perspective here on Earth, it is 6 full moons across. This is no easy feat, especially since the Veil Nebula is 2,100 light-years away. If you're interested, take a look for it, nestled in the constellation Cygnus. The Butterfly Nebula, NGC 6302, is a similarly gorgeous planetary nebula that acquired its name from, you guessed it, its shape resembling that of a butterfly. One may not expect, however, that the gas of this nebula, the more than 2,000-year-old gas from the outside of a dying star, is around 20,000 degrees Celsius, hotter than most planetary nebulae. Or did you know that it's moving at nearly 1,000,000 kilometers per hour? An interesting fact about the Butterfly Nebula is that it is also considered to be bipolar, in the shape of an hourglass with 2 lobes. This is due to the presence of dust around the center of the nebula, blocking light and preventing gas from flowing into those regions. The Butterfly Nebula can be seen if you look to the constellation of Scorpius. If you do, you are looking around 3,000 light-years away. It is also important to mention the famed Crab Nebula. This nebula was actually one of the first astronomical objects viewed by the Chandra X-ray Observatory and has proven to provide an immense amount of information about nebulae and the lifespans of stars. In this case, its gas is constantly expanding, not to mention that it contains a pulsar, or a fast and magnetic neutron star, the remnants of a massive star after it entered its supernova phase. The results of this are intriguing. Along a particular axis, matter and antimatter are ejected. The blue in the image on the left is actually caused by electrons moving through the magnetic field at speeds approaching that of light. The jets of radiation can also be seen to pulse extremely fast thanks to the pulsar, specifically 30 times each second. 6,500 light-years away from Earth, be sure to keep an eye out in the constellation Taurus for this seemingly magical nebula. What are your favorites? Comment in the chat below if there are any particular nebulae that you enjoy viewing.
Well, everyone, you have been listening to the Alan Carswell Observatory's weekly TeleTube broadcast, the astronomy and astrophysics program written, presented, and by the students, faculty, and alumni and friends of York University. The hosts this evening have been Matt, Amin, Noah, and myself, Gagan. Make sure to leave any comments or questions in the comments section of the video and talk to us in the chat right now. We'll be around for the next 20 minutes to answer any of your questions live, so feel free to stick around. All of our programs are free, but if you would like to make a donation, see our website at observatory.info.yorku.ca. You can always connect with us on Twitter and Instagram with the handle at York Observatory and Facebook at Alan I. Carswell Obs. And check out our website for show notes, content, updates, and contact info at observatory.info.yorku.ca. Thanks for tuning in, clear skies, and have a good night.